Hi, my name's Arushi, and I'm a grade 8 student from Toronto, Canada. So my question is to Raymond. I hope I pronounced that right. Um,
Close enough.
okay. So I was wondering that right after the dart impacted, of course, loads of plumes were ejected from Dimorphos. Is there a chance that some of these plumes would have been attracted towards Didymos because it had a much bigger mass and gravitational pull? And if so, would this have changed the rotation period of Didymos slightly because of the additional mass? I asked this because I've done my own research and I've been measuring the physical properties of Didymos before, during, and after the Darwin impact, yet I did not measure any changes in the rotation period.
Okay, that's a really good question. So, I mean, I'm not a dynamics expert. However, I'll give you my layman's overview of this from being part of the DART team. So, yes, there is potential for mass to have basically gone from Dimorphos and hit Didymos, and that's something that's being actively investigated by the dynamics team, by the dynamics team's members. So I would look out for their publications to see what they say. Yeah, there is a small possibility that Didymos's orbit itself was changed, but it's going to be very, very, very small in comparison to the changes to Dimorphos. And we're going to learn a lot more once Hera gets there and can actually in the next couple of years and see what's actually happened and what's left of the system. So I hope that answers your question.
Okay, thanks. Yeah.
All right, so what we'll do now then is we'll sort of move into the discussion portion for about 10 minutes so we don't keep folks for too long. So if you have questions for any of the speakers that have spoken in this session, please either voice them online or if you're in the room, come up to the microphone. Yeah, but could you go to the microphone?
Well, thank you. So
name and affiliation, please. Sorry.
John Cooper, from Goddard Space Flight Center, retired. Thank you.
Thank you.
So just beyond what I was saying in my talk about the Lunasox mission, why should we care about doing a solar corona mission, heliophysics, and so forth? Well, Elon Musk is launching Starlink, thousands of Starlink satellites all the time. The sky around the Earth is becoming polluted with light from all sorts of objects orbiting around the Earth. So going to the moon is perhaps the next step for visual astronomy, right? Near side or far side. And so assessing the optical environment around the moon would be very valuable, as a precursor to, spending billions of dollars building large telescopes on the moon. So I just suggest that as another reason why you might want to care about such a mission as a precursor to lunar astronomy.
Certainly. Thank you. While I've got you, actually, I have a question for you.
Yeah.
Which was, in your talk, you mentioned dust. So some of my research is actually looking at lunar horizon glow and looking at lunar dust. So given that you're essentially in a prime viewing geometry, either on the surface or in orbit for seeing that, would you likely be able to see it at all? Or given that you're geared towards coronal observations, it'll be too dim for you to be able to make it out?
Absolutely. Because lunar horizon glow goes way back to Apollo, and the orbiter observations, which is where this really first starts on this idea. And so definitely one could do a lot of observations from orbit of the lunar atmosphere, the dust, looking towards the terminator, where maybe there's some levitation of the dust. And so, because the brightness sensitivities you need to look at dust, are sort of at the bottom of the range that you want to be looking at the corona with. So, or maybe even higher sometimes. So I think that would be extremely valuable. Yeah.
And is lunar dust then, if it is sensitive, then is that likely to cause any interference with your coronal observations?
I'm sorry, could you say that again?
So if your instrument is sensitive to lunar dust as well, is that likely, because if you're having to look through scattered lunar dust, is that likely going to cause you problems for your coronal observations?
Yeah, I mean, to do a better job, to understand what the foreground is from the scattering light off the dust, it would be a really good idea to do a sort of a precursor, if you're going to think about astronomy in the future, where that might be an issue.
All right, thank you very much. All right, do we have any questions from folks online?
I think David has a hand raised.
Hi, yes, I have a question for you, Nivedita, actually. So actually wanted to clarify a little bit further the status of the pipeline that you described to take into account offsets. So I imagine that the current status of that is, but correct me otherwise, is you basically assuming that you know perfectly the beam except for this offset, right? So basically you just need to figure out how to how to correct for this offset with like perfectly knowing the rest of the beam, right? So my question probably see where it's going. So probably I imagine that the plan would be to test what happens after after you have these corrections set up in a perfect setting, how that would affect when you actually have a real beam and you actually, like your measurements are not exactly the ones as you simulated and so on. So how these can, translate into more problems when you're trying to make this correction.
Oh, thank you for that question. Actually, yeah, that's a good point. There are two things: the beam, knowing the beam well, and knowing the offset properly. So in terms of the beam, right now, I've just made very preliminary assumptions of the regolith. Thankfully, the antenna is not complicated. It's just dipoles. What will be complicated for our beam will be the regolith. That is something I'm looking into too. Like simulating different layers of the regolith, making it multi-layer, and seeing if the bedrock beneath the regolith would affect. That's an independent. To answer your question, it will affect the Stokes leakage, but how much I'm still quantifying. It would be nice. There was talks in Farside. It would be nice to use CubeSats to measure out a couple of beams. Initially, that was in a discussion when we were talking about Farside. It would be nice to have one measurement point in situ once the dipoles are deployed, but that's to be seen. Yeah.
That's good. Yeah, and we probably can talk more offline on that. And then the kind of measurement we're trying to do of the dielectric constant, from roses. That's the kind of also experience probably that would benefit for your setup as well. So we'll see what we can learn for that. But actually, in that direction, you mentioned overall LWA. So are you trying to make actually some tests with actual measurements for preparing into that for Farside as well?
Yes, so we are hoping, we are still working on this. And overall LWA for everyone is a radio array in Bishop. It has about 256 elements. It's very similar to the Farside. It has same science cases. The layout is slightly different, the array layout. And like it has the same problems, the beam, it has additional problems of mutual coupling. It has no problems of the offset. We don't have that, but the beam is definitely a question. And what we are planning for the beam is we want to have ground penetrating radars installed at different part of the arrays and get some soil properties measured at a certain cadence that we can feed into our beam simulations. And that in turn will feed into this pipeline I discussed, so we can make some model images and see and compare that with data we measure. Yeah.
Yeah, that sounds great. That would be great. And it would be also great to test our methods
Yes.
as well. So that sounds nice.
So we have no questions in the room. Do we have any more online?
I just wanted to make a comment about what John said, referring to Starlink, as to how we have to do this quickly and explore the lunar. I wanted to make a comment that Starlink, other than optical, it also starts affecting our radio bands. There was a paper recently by the LOFA telescope in Netherlands that we started seeing leakages of Starlink's emissions into the radio bands of interest for our science case. So it becomes very important for us to start exploring the moon for our radio missions too.
Yeah, actually, I was having the same thought. So we've been looking at this paper as well recently, and it's very interesting that you can see that. And we hope, though, that there'll be some consequences from this paper, and that for next Starlink satellites, they'll try to shield it, because I mean, this kind of indicates that they didn't try to shield it at all, right? Because if you try to put like some kind of Faraday cage on that, that should not happen. I think it seems that they're not trying to even avoid the coolant stack that they should be taking care of. So I guess they didn't do anything on purpose, but this is like, I guess, leakage for the instrument itself, that they didn't try to, probably, again, that's how I guess, I'm not sure, but they didn't try to actually protect. So hopefully they can do that with, with the next series.
Yeah, one can hope that they will mitigate it. Yeah.
Oh, and by the way, they have one more comment for you. I think maybe the second question you were asking me before during the talk, maybe it would be helpful for me to mention that one of the codes that I mentioned Pylonic, but I mentioned Persis. So Persis is the one that deals with programs specifically. So this is the one that we use also for the ground, but also we're using for the moon. So that's another one that what we made recently available.
Okay. Yeah. Thank you. That'll be useful for my pipeline. Yeah. Thanks. Yeah. Yeah, I mean, going back to, we can.
Oops, sorry.
It's almost 5:30 local time. I don't want to keep people waiting anymore. Yeah.
All right. Well, with that, I'd like to thank everybody for coming to this afternoon's session, and I hope you enjoy the rest of the conference. Thank you very much, folks.